An airplane travels on a bearing of north. I'm not even answering that. You should look that up. Chapter 7, sir. North 35 degrees east, I think, at an airspeed of 500 miles per hour. A wind is blowing from the northwest at a speed of 45 miles per hour. Find the ground speed and bearing of the plane in the wind, and what it should say there is using the magnitude of vector u is the, I'm sorry, that's not correct. I know. Vector u is of the form the magnitude of vector u times the cosine theta times vector I plus the sine theta times vector j. So we got to use that. Now you've seen this problem before. The way you did it before was by drawing a picture and using your friend the law of cosine. We're going to do it again, but now in terms of the IJ format of a vector, a linear combination, if you will. We're going to have two vectors here. We're going to have a plane vector and a wind vector. And we're going to find the plane plus wind vectors combined. So let's start off with the plane vector. So the plane is on a bearing of north 35 degree east, so that's in quadrant 1 somewhere, where this is 35 degrees. And the magnitude is 500 miles per hour. So for the plane vector, it would be the magnitude of the plane. What's the magnitude of the plane? 500. He says confidently. Times the cosine of theta. What's theta? What do you think? It is 55 because that theta there is what's coming from the positive x-axis. So what happens if your picture's wrong? Well, there goes the whole problem. Yep. Yep. You lose more points than what it's worth. Cosine of 55 degrees, vector I. Sine of 55 degrees, vector j. Let's talk about the wind. The wind is blowing from the northeast, which means it's really headed what? Southwest. Magnitude is 45. I didn't mean to put a degree symbol there. 45. Boop. So the magnitude is 45. What's the angle that would create that vector? So if it's blowing in the southwest direction, exactly southwest, otherwise they would have said something else. No, remember, from the positive x-axis. 225? So here's the thing. We're going to find vector P plus vector W. Vector P plus vector W would result from adding these two vectors up. So on the left, we added the left, vector P plus vector W. On the right, we add these guys here. notice we would have like terms. If we distributed 500 through, we get 500 cosine 55 degrees vector I plus 500 sine 55 degrees vector j. And something very similar for the second one. So since the first term in both parts would both contain a vector I, we could pull out that vector I. We would be left with the coefficient 500 cosine of 55 degrees plus 45 cosine, not going to make it, 225 degrees. Oh, barely made it. So we're literally adding both sides. So 500 cosine 55 degrees plus 45 cosine of 225 degrees is the coefficient of vector I. So what's the coefficient of vector j? So you want to imagine that you distributed these through. Good. 500 sine of 55 degrees plus very good. Tasty. Rounding to two decimal places, let's go to. What is 500 cosine of 55 degrees plus 45 cosine of 225 degrees? That's a good story. Let's turn back to math. What is 500 cosine of 55 degrees plus 45 cosine of 225 degrees? And for vector j, 377, excuse me. Based on the problem, why should we expect the coefficients of vector I and j to be positive? Based on the problem, why should we expect the coefficient of vector I and the coefficient of vector j to be positive? How fast is the plane going? Much greater than the magnitude of the wind. Yes. So even though the plane is going, it's basically going almost northeast. It's off by 10 degrees, if you think about it. The wind is coming from the northeast, so that means it's heading southwest. So the plane is pretty much directly flying right into the wind, for the most part. It's going to be moving down a little bit. For the most part, it's right into the wind. With that stated, we shouldn't be knocked into another quadrant because the wind's not strong enough and it's not really blowing it into another quadrant. Now, if it was coming from the east, yeah, we might get knocked into quadrant 2 if the wind were a little bit stronger, but 45 miles per hour, probably not enough to knock it that way. However, since the plane is going into the wind, not directly, but close, when we find the ground speed, i.e. the magnitude of this vector, should it be greater than or less than 500? Less than, because it's losing some speed. Okay? So we pretty much have component form here, because 254.97 would be the horizontal component, 377.76 would be the vertical component. So we can now answer, find the ground speed of the plane. We needed all this stuff to get to here. So to find the ground speed of the plane, that's just fancy talk for the magnitude. What is the setup for the magnitude? Yep. So third time we did this today. So if you would, let's round that to two decimal places. I got 455.75. Hooray! So again, it met up with our prediction that it should be something less than 500. Notice we almost knocked off all 45 miles per hour. Well, if the wind and the plane were going in true opposite directions, it would have just been a subtraction problem. Yeah. So yeah, so at least we have an idea. You can't, yeah. So if the wind was going in the same direction as the plane, we couldn't be any more than 545 miles per hour. So you have some ways of knowing if it makes sense or not. How do we figure out the bearing of the plane? I'm sorry, the bearing of the plane in the wind. Let's clean some stuff up here. So what we just found in this teal color here was the component form of the plane in the wind, meaning we would go over 254.97. We would go up 377.76. So this vector would represent the plane in the wind. So we need to figure out what this angle is here. The 455.75, but we don't need that. You can use it, but we don't need it. So by design, this is the right triangle here, yes, where one of the legs, the leg opposite of theta would be 254.97. The leg adjacent to theta would be 377.76. So what function can we use? What do you call a nice guy that goes outside in the sun? Tangent. Tangent. Get in? So the tangent of theta would be opposite. Yes, Cosby. Over hypotenuse. We got to clean some stuff up over here. We don't need you. We don't need you either. You're gone. By design, we're going to get this angle theta directly by taking a tangent inverse. What is the tangent inverse of 254.97 over 377.76? 34.02. Looks good. So you get theta to be approximately 34.02 degrees. So what's the bearing of the plane? Good. So the original bearing was 35 degrees. The wind knocked it over a little bit. 34.002 degrees.